Good day, Mambatukan. This is Jaza di Baguio. The title of my mathematical investigation is Encircle the Polygon. So here's the table of contents. Introduction. Circle and polygons are both part of the study of geometry. These shapes are actually part of the things around us, especially nature. Plants, rocks formation, natural features, architectural designs, human features, and many more use circles and polygons. These figures enhance the beauty of all things around. The area of the circle is computed based on the product of the constant value of pi and the square of its radius. Polygon's area is generally computed as one half of the product of the number of sides, the length of the sides, and the length of the apothegm, which is area of the polygon equal to NSA divided by 2. The researcher then would like to find out if there is also a common value to solve for the common areas of the circle and its inscribed regular polygon using a shorter process. So here's the statement of the problem. The researcher aims to find out if there is an easy way to determine the areas of the circle and its inscribed regular polygon. Specifically, it aims to answer the following questions. Number 1, is there a common ratio between the area of the circle and the area of its inscribed regular polygon? Number 2, is there a common value to shrink the circle so its area will be equal to its inscribed regular polygon? So here is the investigation or showing data of specific examples. I have here three tables. The first table is the circle and its inscribed square. The second one is the circle and its inscribed pentagon. And the third one is the circle and its inscribed hexagon. But ako rang i-discuss ang the circle and its inscribed square kay same process naman ang tulo. So, in the second column is the length of the radius of the circle. The length of the radius of the circle increases from 1 to 25. Then the second column is multiplied to itself, then multiplied to the value of pi to get the third column, which is the area of the circle. Then, the fourth column is the area of the square inscribed in the circle, derived from this equation 2r squared divided by 2, where 2r squared is the diameter of the circle. Then the fourth is then multiplied to the third column to get the ratio in the fifth column, where the entire given radius have the same ratio. So, di ba, ang atong radius, ang atong length of the radius sa circle is nag-increase man. So, from 1 to 25. But, pero, ang atong ratio is nagka-same ra Japon, as you can see in the table. So, the ratio in the fifth column is multiplied to itself to get the value in the sixth column. So, in the value of the sixth column, muna siya ang atong i-multiply sa radius para makakuha ta og new radius sa circle. So, the value of the sixth column is multiplied to the second column to get the new radius in the seventh column. So, di, muna siya. Then, the process 2, natong pagkuha sa area of the circle is repeated. But the value of the seventh column is used as the radius to get the new area of the circle in the eighth column. Then finally, the new area of the circle in the eighth column is found out na equal sila sa area of the square in the fourth column. As you can see naman, di ba, ang area sa square o ang area sa circle is nagka-same sila. So, the same procedure were done in the other two polygon, which is the pentagon and the hexagon. So, with the illustrated Excel output in the tables 1 to 3, it is then observed that the ratio is still the same, even if the length of the radius increases. Thus, the researcher made two conjectures. So, here's my conjectures. So, conjecture 1, if a regular polygon is inscribed inside a circle, then there is a common ratio between their areas as the length of the side of the square and the radius of the circle increases. the conjecture 2, if a polygon is inscribed inside is a circle, then there is a value of g that can be multiplied to the radius of the circle, so that the area of the circle will be equal to the area of regular polygon inscribed in the circle. So here is my verification of proof. In the equation AC equal to AS, where AC is the area of the circle and AS is the area of the square. So AC is pi r squared, where r is the radius of the circle, and AS is d squared divided by 2, where d is the diagonal of the square. So AC, area of the circle, equal to pi r squared equal to pi v squared over 4, where d is the diameter of the circle. But ako siyang i-discuss first ang ano siyang na himog pi d squared over 4. So, di ba ang r is kuan man, d squared, d over 2. And then ang pagkuha sa area of the circle is pi r squared. So, since namatay value sa atong r, so atong sang i-substitute sa equation sa pi r squared. So, inani ang itsura. And then sa distributive property, i-distribute ang 2 sa d og 2. So, mo na siya ipagkuha. So, pi d squared over 4. So, the reason why nganong inana siya sa area of the circle kay para magka-same, para latong ma-distinguish ang sa d sa square o ang d sa circle. So, mo na siya figure or mo na itsura sa the circle and its inscribed square. So, mo na itsura sa kung atibutang ang square sa circle. So, let d squared over 4 and d squared over 2 to distinguish the d of the square and the circle. So, let the value of g multiply to the d to adjust the diameter of the circle in getting the area of the polygon. So, area of circle equal to area of square. So, area of the circle, di ba nato is pi d squared over 4. Ang area po sa circle square na to is d squared over 2. Next, to assume that there is a value of g that can be used to shrink the diameter of the circle, which is equal to the diagonal of the square. So, di ba, so atong i-multiply, di ba, nakabutan dito is atong multiply ang value of g sa diameter of the circle. So, mo na siya itsura. Then copy lang sa formula, sa katong formula sa area of the square. So, sunod ana atong i-distribute ang 2 sa d and g. So, ang itsura na is pi d squared g squared over 4, and then copy lang sa pikas, d squared over 2. And then, ato siyang i-cross multiply. So, pi d squared g squared times 2 is equal to 2 pi d squared g squared. And then, 4 times d squared equal to 4d squared. So, divide both sides by 2 pi d squared so that the value of g will be remain. So, ato i-divide both sides by 2 pi d squared. So, then atong kanang 2 pi d squared kay ma-eliminate man na siya, so ang mabilin diri sa pikas is g squared. Ang sa pikas is 2 over pi. So, and then in order to para mawala ang to the power of 2 sa g, so ato siyang square root. So, g equal to square root of 2 over pi. So, Therefore, the square root of 2 over 5 is the value of g to shrink the area of the circle. But this is only for the square. So furthermore, we need to find out or to find the common value of all regular polygon inscribed in the circle. So for the equation of area of circle and area of polygon, where area of polygon is the area of where AP is the area of the polygon. So the area of polygon of the formula in getting the area of polygon is nr squared sine 360 over n divided by 2, where n is the number of the side and r is the radius of the regular polygon inscribed in a circle. So here's the figure of the the circle and its inscribed regular polygon. So nadira ang radius sa circle ug napo ang radius sa polygon. So let pi r squared over nr squared sine 360 over n divided by 2 to distinguish the radius of the circle from the radius of the polygon. Find the value of value of g to get the area of the polygon given ang area sa circle. So AC equal to AP. So where AC is pi r squared and our AP is this nr squared sine 360 over n divided by 2. Since the radius of the circle should shrink, so the value of g is multiplied to the radius of the circle para ma-shrink ang area of the circle. Ang radius sa circle. So, i-multiply nato ang value of g nato sa radius sa circle. And then after ana i-distribute ang 2 to the power of 2 sa r and g. So mo na itsura pi r squared g squared, and then copy the formula of the area of the polygon and then cross multiply. So 2 times pi r squared g squared is equal to 2 pi r squared g squared, and then nr squared sine 360 over n. And then both side divide both side by 2 pi r squared so that g will be remain. So divide both side, and then g squared will be remain, and here is in the other side is n sine 360 over n over divided by 2 pi. And then ato siyang square root ang g squared para mawala ang to the power of 2 sa g. So muna siya. So g equal to n sine 360 over n divided by 2 pi. So therefore, the value of g equal to square root of n sine 360 over n divided by 2 pi can be multiplied to the area of the circle to get the area of the polygon inscribed in the circle. So, since naan naman tayo equation na makamultiply sa area sa circle to get the area of the polygon inscribed and it's inscribed regular polygon. So, natay theorem. So, ang theorem is para natay to solve the common area of both shapes. So, ato yung gamito ning formula. So, let area of the circle be the area of the circle. Let AC be the area of the circle and AP is the regular polygon. Is the area of the regular polygon. Then the area is equal to pi r squared using the value of g that we project. Then the area of the polygon is equal to. So, di ba naman tayo na-project na value of g to shrink to multiply the radius of the circle. So ato siyang ang atong na project na value of g ato siyang i-multiply sa radius sa circle. So mo na siya itsura. So thus the area of the circle is n sine 360 over n divided by 2 pi or pi r squared n sine 360 over n divided by 2 pi. So, depende na ninyo kung unsa inyong gamiton kanibang na ay AC or kanibang na ay active mo ikuan ang pi r squared. So, application. So, Sample problem is herbal illustrated. So a regular hexagon is inscribed in a circle with the area of 30 cm squared. What is the area of the inscribed regular polygon? So given ang area sa circle, 30 cm squared, and then ang number of sides sa hexagon as a regular hexagon is 6. So solution in getting the common area. So di ba naman tayo formula na na-formulate kaning AC n sine 360 over n divided by 2 pi. So muna to ang gamiton na formula to get the common area of the both shape. So AC and sine 360 over n divided by 2 pi. So, ang area of the circle na to is 30 man, di ba? So, substitute lang. And then, ang number sides of regular hexagon is 6. So, substitute lang sa n. And then, ato siyang divided by 2. So, 30 divided by 2 is 15. And then, mawala ang 2 sa inlalom kaning dire. So 15, so mahimo siyang 15 sine 6 sine 60. So 360 divided by 6 is equal to 60 divided over pi. So and then i-multiply ang 15 sa 6, so mahimo siyang 90 sine 60 over pi. And then atong simplify ang sine 60. So ang sine 60 is square root of 3 over 2. So muna siya itsura. And then atong divided by atong i-divide ang 90 sa 2. So ang mahitabo is 45 square root of 3 over pi cm square. So muna na ang common area sa both sa both shapes, which is ang 45 square root of 3 over pi cm squared. So, muna na siya ang application sa atong formula na atong nahimo. So, conclusion, based on the findings, the following conclusions were reached. So, the first conclusion is there is a common ratio between the areas of the circle and its increased regular polygon, even if n and s is even if the number of sides and the side of the circle increases. There is a common value to make number 2 is there is a common value to make the area of the circle and its inscribed regular polygon equal with which is the value of G. So, recommendation, based on the findings, the following recommendations are made. So, first is the finding will be applied in teaching geometry, for this is the shorter way in getting the area of inscribed polygon. The second one is make a further study on the application of findings in the real life. And the third one is the findings will be applied in getting the area of inscribed polygon if given the area of the circle. So here's my references. So that's all. Thank you.